The next topic, this is not going to really take a lot of time, is EtherChannel. And EtherChannel is kind of a cool thing. What we're going to do is bond or bind interfaces together to make them high-speed interfaces. And I think probably what I want to do is just start out with the demo and then do the slides. There aren't that many slides too here, but connecting two switches together, and we've been looking at spanning tree, and you say, yep, that's right. We have 4 lines here connected together, and only one of them is conducting data from one side to the other. We'd like to make this a high speed. These are 100 megs. We'd like to make this a virtual 400 meg connection. To do that is what EtherChannel is all about. So when I go into this thing, and it's config T, yes, I better enable and then config T, and then interface range, fast Ethernet 0, 1 to 4, I think is the ones that are connected there. And now we can do channel group 1, and then the mode. And this is the other side is already configured, by the way. So you do this mode, and when we do mode here with a question mark, we have 2 different protocols. LACP, Link Aggregation Control Protocol, which is the standard, and then PAGP, Port Aggregation Group, which is a Cisco proprietary protocol. And if you look at them, active says does it unconditionally, desirable says does it unconditionally, and desirable and auto will form an ether channel, desirable and desirable will, 2 autos won't. Active and passive, and those are a little bit more obvious, I think. Active, passive, active and an active will, an active and a passive will, a passive and a passive won't. I'm going to do PAGP because, and I'm just going to do mode desirable because I think that's what's on the other side. We'll find out here in a second. And then after that, the question mark, the only thing we have here is a carriage return. So it says that it changed, the port channel changed status to up, and let's see if it actually did. Let's go show spanning tree for this thing, and sure enough it did. PO1, I'd already done some configurations before so that you didn't have to watch it go both sides. It's a pretty straightforward one. This is the root port, which means it's going to the root bridge. It's in learning state. The cost is 7, so we have now put together those 19 costs. Now we're in forwarding state. The cost of 19, the 100 meg interfaces, consolidated 4 of them, and our cost now is 7 to get there for the spanning tree. There's only one way we're going to go, but it changes the cost. The PO1 is the port channel 1 is the virtual channel that we have with this thing. We can show ether channel, and it tells us that we have a layer 2. 4 ports, maximum number of ports are 8, and the protocol that we're using is PAGP. 2 protocols, PAGP, LACP. Pretty straightforward configuration for these things. This allows things like NIC teaming, I think is what Microsoft calls it, where you have multiple NICs in a device and you can bind them together to create a high-speed link. What this now allows us to do, and the protocol will send some of the data across each of the links as we do. And you see we have all 3 of them here in green. And we haven't created a loop because we created a virtual interface, a virtual connection to go one from the other. So we could combine these things together to create a single high-speed link for more efficient utilization, I guess, of the devices itself. Cisco Link Aggregation Port Trunking Technology, and the Cisco proprietary one is going to be PAGP, combines individual Ethernet links into a single logical link, the channel group that we used when we grouped these things together. We can aggregate up to 8 physical links to do this. And, then that's going to be a pretty good connection if we have like gigabit ports. An 8 gig port is a pretty reasonable thing. Where would we want to do this? As this one shows, when we're linking 2 switches together, because we've got a whole bunch of traffic down here that going into the switch and now has to be shuttled into a single connection to get off of the switch. So we can do those things. It's fault tolerant, high-speed links between switches, routers, and servers when we do this. All of the LAN ports got to be configured with the same speed and duplex, and I think that shows up a little bit later. And got to be configured as either a layer 2 or a layer 3. We can configure layer 3 Ether channel on layer 3 switches if we needed to do that to give us the high speed. And this would go back to the servers. That we had a server that we needed high-speed connections to, maybe a database server. A lot of individuals are connecting to and making changes to it. We need a high-speed connection to it. We can do port teaming on the server and then do some sort of an Ether channel, either PAGP or LACP, to bind the other end of it together into a virtual connection to go from one to the other. The configuration, manually, the interface range, which we did, you saw that. Switch port trunk encapsulation, I had already given the switch port mode trunk commands. We hadn't talked about those. We will tomorrow when we do VLANs. We're going to have access ports and trunk ports when we do those things. The trunk ports, as a spoiler, the trunk ports connect the switches together. Trunk ports go from switch to switch. Access ports go to the devices to access the switch. Channel group 1, mode on. There were 3 modes actually. One was PAGP, LACP. The other was on. If we use on, we have to do on both sides. PAGP and LACP will negotiate to create the Ether channel, and they generally recommend that you use one of the negotiation protocols. The spanning tree link type is a point-to-point, and then we use the no shut command in order to bring it up. Mine came up because it's been done a couple of times. And let's see, I'm going to see something, see if it does show up as I think it shows up as in the channel group, it shows up as a shared SHR, which means that it's more than a single interface to go to these things. So we have the protocols here, all the standard things that we would expect to see in the show spanning tree, and the cost down here relatively low for this device. When we do that, PAGP, Cisco proprietary, and when we configure this PAGP, LACP, we got to pick one or the other. If one side's PAGP, the other side's got to be PAGP. We can't have a PAGP and an LACP. Different protocols, different languages. They don't talk to each other. It's kind of like having a Chinese on one side and an English on the other side. Not really going to communicate very well. LACP, Link Aggregation Control Protocol, IEEE 802.3d, the standard, and both ends have to be LACP. One can't be PAGP or manual. They have to both be one of the protocols. This is active passive. It could be an active on one side, a passive on the other, an active on both sides. If we had a passive on both sides, it's just not going it's not going to form a link when we try to do that. These are the negotiated. The on just says just do it when we do those things. But the negotiated Ether channels protocols are enable the automatic creation of the ether channels. PAGP, auto and desirable. Auto enables it only if the other side is not an auto. And I would say probably more accurately only if the other side is a desirable, because the not auto, the other side could be an on, and that's not going to work either. If we use on, both sides have to be on. LACP, active and passive. Active and a passive will, an active and an active will, a passive and a passive will not. In the auto and desirable, desirable will, desirable and auto will, an auto and an auto will not. An auto only will form a channel if the other end asks it to, and the only one that has any ability to ask it to is going to be a desirable. Negotiated channels will form if the configurations are exactly the same. They do have to be the same on both sides. The port and duplex have to be the same. They either have to be trunk ports or access ports. They're going to be mutually exclusive. If one side's a trunk and one side's an access, it's not going to work. Access, trunk to trunk to do these things. Got to be in the same VLAN, native and allowed. That's something that when we do VLANs, hopefully it'll make more sense after tomorrow when we talk about VLANs and allowed VLANs for the different elements. The same spanning tree protocol settings. STP regards the ether channel as a single link. We saw that it was PO1 because it was channel group 1, port channel 1. And it's treated as an individual link. If we should go into here and let's shut one of these guys down, Fast Ethernet 04, big T, interface, Fast Ethernet 04, and do a shutdown command on it. It is shut down, and if this will ever go away on the port number, the others, and hopefully you can see in the background here, are still green when we look at it. So the shutting down one port does not destroy the channel group. It just reduces the data rate that's going to be available. So let's try show ether channel now. It still says we have 4 ports configured, but only 3 of them are going to be active. Let's see what spanning tree says. Didn't need the end. It's still got a cost of 7. It hadn't done the recalculation yet to see, because you can see it's kind of stuck here in the simulation. But one of the advantages is one of the ports goes down. It just simply, the protocol will do a recalculation as to how to share the data from one to the other. One of the other interfaces will pick up the load for the interface that we lost. So it's a single link. PAGP aggregate up to 8 physical links. LACP can aggregate up to 16 ports, but only 8 of them are used at a time, which means that the situation that we just had, if we had 16 of them configured and 8 of them are active, and one of the active ones goes down, it will be automatically replaced with one of the already configured interfaces on it. So will they or won't they form a channel group? Auto and an auto here is it won't. Everything else will in the auto desirable world. LACP, a passive, and a passive won't. Everything else will in the LACP world. So there are some labs, and show CDP neighbors, a couple of those, LACP channel protocol, different configurations that